Alright, so what we have is a little warm-up here, basically from derivatives, including logs, through curve sketching and some basic Riemann sums type of positions, chapter 5 in the Stewart book. So number 1 is just differentiate each function. First one's the power rule. It doesn't matter that it's fraction, right? So you bring the 3/2 times the -2, and you reduce the power by 1, and I think you get y prime equals -3/2 x to the half. I would imagine for 2, finding the derivative, you guys did the quotient rule. You could do this as a power rule, or a product rule, I mean. You could bring x to the 4th plus 3 up. You could do it this way, guys. Now that we're good at chain rules, sometimes that is easier if you bring up the denominator. If I do the derivative here, though, as a quotient rule, derivative of 2x cubed is 6x squared times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. And again, if you're taking this on the AP test, you'd have to take some time to simplify. This is a time where I notice you're going to have some like terms, so you're going to have to distribute. Because it doesn't say don't simplify. There's the numerator when you distribute. So I get what? -2 x to the 6th. Alright. Plus 18x squared over x to the 4th plus 3 squared. And guys, if you were finding critical points, you would have to get to that point. Alright? So you could factor the numerator and see what made it 0. Critical points happen at that point. Yeah. Right there at the bottom. Yep, right at the bottom I did. Yep, you can combine those, and that's what I did. And you should, because then you would factor out if you had to find the critical point. It didn't ask for that, so I'm not going to bother. Everybody, I'm going to work in order. Use logarithmic differentiation to differentiate each function with respect to x. First of all, you should see that you had to use a log, guys. I shouldn't have to tell you, because are we able to take the derivative of 4x raised to the x? No. We don't know how. You guys agree? So I am going to take the natural log of both sides. ln y equals ln 4x raised to the 2x. Our power of logs from pre-calculus means I can do this. And I have ln y equals 2x times ln 4x. Everybody, I see a derivative on the left with y in it, and I see a product rule derivative on the right side with 2 x's in it. Alright? So, if I move those down and get them on some white space so they're a little easier, extend the page, this becomes a big exercise. Alright? And I'm starting from y equals what? 4x raised to the 2x. So derivative of ln y is 1y dy. You guys agree, right? But I'm going to raise y prime immediately. On the other side, I'm going to do the product rule. The derivative of 2x is just 2. Alright? And the derivative of plus 2x times the derivative of ln 4x, 1 over 4x, times 4. Right? Derivative of 4x is 4. And those are both dx's, but since I divide by dx immediately in my head, I get this. So my final answer here this time, doing some simplification, is y prime equals, and guys, I multiply both sides by y. Y times 2 ln 4x. 4's are going to cancel. The x's are going to cancel. Ha! I get 4n lx plus 2. I could factor a 2 out, it looks like, but alright. But everybody, we don't leave y prime equals y in this case because we know what y is up here. Right? So my last step is to substitute that back. 4x to the 2x power. And again, it's possible, and I haven't looked at the answers on this, it's possible that the answer book would factor the 2 out and put the 2 in front instead of leaving a 2 in both terms inside. I'm not going to bother. And that's the derivative. Everybody, if I had to find the critical points, all right, if I had to find the critical points, I would use this to solve for 0. And again, we found the derivative, and this is the only way to do this problem. There's no other way to handle it, all right? When you have an x up in the exponent area, you have to get it down to the bottom so we have our rules, okay? The last one, and this one, now this third one probably wouldn't be on a quiz anytime soon. We're still working at it. Again, you can use con to practice it. The third one is definitely on any time I want now. Increasing, decreasing, concavity, critical points, points of inflection. You should be able to identify all those. Find the open intervals where it's concave up or down. Well, concavity is determined by the second derivative. So the first step is to take two derivatives. All right, I'm going to write dy dx today so we see some different notation. Negative 4x cubed minus 6x, and then d squared y dx squared, the second derivative, is 12x squared minus 6. You guys agree? All right. I want to know where there's zeros. If I'm going to figure out signs, I want to use zeros as my breakpoints. So I'm going to set this y prime prime equal to 0. And I can see x squared equals a half, right? So x equals plus or minus the square root of 1/2. All right. I can make a quick little table to help myself out here. All right. I'm going to make myself a quick little table to help myself out so I can figure out the signs. I get 1 over square root of 2 negative, 1 over square root of 2 positive, and I have those regions. And I know f prime prime is 0 here, 0 here. I have 3 regions. I got to get signs in these 3 areas. I got to get the signs in the 3 box areas to know the concavity. And I imagine because it's an interval, we did that. I'm going to take 1 divided by the square root of 2 because I need a decimal. 1 divided by 2 is like 0.7. No, don't even care because we're doing concavity. Don't even care. We don't want to waste time. I plug 0 into the equation in between the two, and I get negative, right? 0 minus 6. I go, and then I look, it's 12x squared. Guys, we should recognize 12x squared is going to be positive on both sides. So we can quickly say the signs here are positive. Everybody, I see that I'm going to have to use these numbers in my interval. You guys agree? So we would rationalize those. I'm assuming we can do that pretty quickly. So I would do concave up first. It's negative infinity to negative square root of 2 over 2. And from square root of 2 over 2 over to infinity. The only place that it is concave down is in between, so we just write concave down, CD. That happens from negative square root of 2 over 2 to square root of 2 over 2. All right. Pretty straightforward. There are 2 points of inflection. You guys agree they happen at the 2 zeros this time because there is a change in sign of the second derivative. They don't have to be 0. There has to be a change in sign. And I could find the y value of the point of inflection by going back to the original equation. I am not going to, because that would not be a fun thing to calculate. All right? All right. I got 3 more I want to do for you today, because these would all be fair game for quizzes now, okay? And I want to make sure we understand the 6th one, and I'll do these if you want to follow along. For each problem, find the average value of the function over the given interval. Guys, again, once it says average value, you've got to think secant line. This is just the difference between f of b minus f of a over b minus a. This is just a slope using these points. So the first thing you're going to calculate is plug in 3, plug in negative 1. Does anybody know the answer already? All right. I don't know if anybody here knows I know the answer by looking at the function, but I'm going to go through it anyway. All right. So the way to do this then is change in y. So negative 5 minus a minus 1. over the change in x, and I get negative 4 over 4. I want negative 1. Is the average change of the function. Everybody, you should probably have saw that right away because this is a line. All right? It's a line. And guys, when you have a line, the change between 2 points is a straight line, right? Well, it's a straight line already. The slope of the average rate of change and the instantaneous rate of change is the same. All right? And again, if we understand that as we move forward, that'll save you some time. Likewise, if you want to prove the mean value theorem on this one, every point in between the numbers, every point between -1 and 3, the c, it'd be every point in between. There'd be an infinite number of c's. All right, so for the next problem, for each problem, find the area under the curve over the given interval. Set up, but do not evaluate the integral. This is new for us. Again, we have a function. They say, hey, here's a graph of y equals 1 over x squared. They want the area under the curve from 2 to 5. Guys, this is just a notation exercise. And this happens a lot as we move forward, because a lot of times we're going to move forward to use our calculators to set up integrals. So, everybody, if I want the area under the curve, I got to say, what are the intervals? Well, I'm going 2 to 5. What's the function? And we have to do it with the differential of, boom, there's the area under the curve. Set up, but do not integrate. That's done. And again, I use red because that's something we're learning. I wouldn't put it on a quiz next week, but it's coming. You should put it on a quiz if you like the easy stuff. I like putting old stuff on there, stuff you should know. Stuff you forget, I know. Yep. All right, for number 7. For each problem, find the equation of the line tangent to the function at a given point. They want slope-intercept form. I'm going to put it in point-slope form still, and still solve it. If I'm going to get a tangent line, I have to get the slope of the derivative at that point. So I'm going to have to get y prime still. Right? And I have the point, it's 0, negative 4. So now the question is, what's the slope when x is 0? By coincidence this time, what's the slope when x is 0? 0. I love easy problems. Because now I have the slope of 0. I have the point, the y-intercept is 0, negative 4. Guys, we should know just immediately that a slope of 0 is a horizontal line. But I'm going to go through point-slope form anyway. So it's y minus a minus 4 equals 0 times x minus 0. You guys should see that this all goes to 0 on the right. Move the 4 to the other side, I get y equals negative 4. Of course, we knew that it had to be a horizontal line. Because when you have a slope of 0, it's a horizontal line. Now remember, an undefined slope for a derivative means the line is vertical, right? We also have undefined slope. All right, just some warm-up, some stuff we're prepping, okay? Good practice for the AP.